All right, so the biggest difference between solving linear equations and linear inequalities is that when you're graphing an equation, the solutions are the point that are on the line. When you're graphing an inequality, the solutions are all the points that are either above or below the line. So this has all the points that are on that line. Okay, they're only the ones that are on the line though. This one, because it's a dashed line, actually the points on the line are not included in your answers. However, all the shaded area, all of these points are considered answers to a linear inequality. So one method of determining which side to shade is to choose a point anywhere. So we talked about doing that. So what you would do is after you get the get it into y equals mx plus b form, remembering everything that we did with inequalities, and you graph it, you would pick a point somewhere on this. So 0, 0 is always a good one to use. And you would substitute 0 for x and 0 for y, and you see if it's a true statement or not. So because the statement's false, and this one, that point's below the line, you wouldn't shade there. But there's an easier trick to it. When you're done, if you've made sure to flip your sign when you divide by negatives and you know that you've graphed the line correctly, you can simply look at this symbol right here. This means greater than. If it means greater than is above the line. If it is a less than symbol, that means you're going to shade below. Alright, so greater than symbol means that you're going to shade above. And less than means you'll shade below. And that goes for greater than or equal to and less than and equal to as well. So the difference between the or equal to sign is that this is going to be solid lines and this one's going to be dotted lines. So if you take a look, it says the boundary lines for each inequality. And if you think about these lines, it truly is, it's a boundary line. It is the boundary, the splitting between solutions and not solutions. So really it's like almost drawing a boundary on a map. So the boundary lines for each inequality are already graphed. Shade the correct side. So if we look here at the greater than, and we know, and I don't mean to make it look like or equal to, so I'm going to circle it instead. So I look here at this greater than sign, and greater than means above. So I take a look at this, and if the best way to do it is start right here at the point where it would cross the y-axis, and I want to shade the part of the y-axis that's above the line. Well, I want to shade everything else on that side as well. So you start with the y-axis and then you just start shading in from there. That's the very best way to do it. You start at your y-intercept and you go with the direction the sign tells you to. In this case it was above. So even though this doesn't look like it's really sitting on top of the line, because it includes the part that is above this boundary line, then I know I've shaded the right side, or the correct side. So if I take a look here, this says less than. So I'm going to go to my y-intercept, which is right here, and I want to shade the part of the y line that's less than, which is below. And then I'm going to shade everything else that shares that side. So I'm going to shade everything over here. So if you'll just start at your y-intercept and then shade above or below, and then just you can finish filling in the whole rest of the side from there. This next one is the boundary line x is greater than 3. Well, it goes straight up and down, so it really doesn't have an above or below. It truly doesn't have above or below. But it is an x is greater than 3. So if I take a look at this, at 0, x is not greater than 3. If 0 is my value for x, that's definitely less than 3. So it's not this side of the line, but it's this side of the line. If you want to check it out, you can say, okay, what about when x equals 6? Well, when x equals 6, it would say 6 is greater than 3. Well, that's true. So I'm going to shade over here. And that's how you decide which side of the line to shade. So to graph a linear inequality, you just solve the inequality for y and then graph the boundary line. You got to keep in mind that if it uses less than or equal to or greater than or equal to, you have to use a solid line. Without those lines underneath, you used a dashed line. So after you're done graphing the line, so you solve it for y, graph the line, and then pick which side to shade. So it tells you, it wants to know what are all the solutions for 2x plus y is less than or equal to 4. So the very first thing I'm going to concentrate on doing is getting this y by itself. So I'm going to get rid of this plus 2x using subtraction. So I'm going to subtract the 2x, and I end up with y is less than or equal to negative 2x plus 4. Well, that takes care of the y. It's done. I don't have to divide by anything. I didn't divide by a negative, so really at this point it's finished. So the line they graphed is at 4 with a slope of negative 2, and they went down and to the right, down and to the right, or up and to the left. And they graph this line, and then if you take it, and we know it's going to be a solid line because of the or equal to part of this symbol right here. And then you got to determine which side to shade. Now they went back to pick their test point, but right here I see less than. So if I start at my y-intercept, I can shade everything less than and then everything on that side of the line. So if we're going to take a look right here, it says graph the solutions of each linear inequality. So I'm going to start by getting the y by itself. I'm going to add x to both sides. Okay, and I get y is less than x plus 3. So now y is completely by itself. So I'm going to plug in my plus 3, and I am going to go in the positive direction, up 1 and to the right. And this is a dashed line. So we're going to do a dashed line straight through. And now I need to determine where to shade. So I look here at less than, and I'm going to shade the section that's less than and everything over here. Alright, and now this one, well, everything is over here, so I need to get the y by itself. So I need to subtract the 2, and I need to subtract the x. So I'm going to subtract x and subtract 2 from this side as well. And I get y is greater than or equal to negative x minus 2. Plug in the minus 2. I'm going to go a negative slope, so down 1 and to the right. So one negative direction and one positive direction. I'm going to graph my line. It's a